Hello everybody, I will start my today's another live coding session. So today I solve this question. Power xn. Implement power xn, which calculate x raised to the power n. So x to the n. Okay. So let me clarify my understanding first. So in this question, wait a minute. So in this question, I'm given x, which is, I take a look, number, and also I'm given n, which is actually integer. Okay. And I will return some number, which is x to the n. Okay. And as the constraint, x is not 0 or n is larger than 0. So if x is 0, what happens is n is larger than 0. So in this case, so I can say, actually this is the edge case. So when x is 0, n is something like 1 or 2 or something, maybe 1.1. No, n is integer, so maybe 1 or 2. Then I should return 0. Okay. Aside from that, the edge case I have to take care is, let's say x is 2 or maybe negative 2 and n is 0, I should return 0. Maybe I have to treat this as an edge case. Okay, anyway, this is something I have to take care. Aside from these edge cases, so let's say x is 2 and n is 3. In that case, I will return 2 to the power of 2 to the 3, which is 2 times 2 times 2 is 8. Okay. So definitely the brute force approach is I just use this operator. I should say this in Python. But probably it takes too much time. Let me check. So in this approach, the time complexity should be, so I have to calculate the, multiplication n times the O of n. And if x is large, it can take a lot of time, obviously. Because multiplying larger number takes more time than multiplying smaller numbers. Yep. For space, it should be constant. I don't need any constant data structure. Let's optimize this. So what I can do here is, let's say I try to multiply n 3 times. Or let's say, like this. Seven times. In that case, if I calculate this, like 4, I actually know this and this and this. Yep. So I don't have to calculate this anymore, 2 times 2, because now I know this is 4 and 4, and this is still 2. And here, if I calculate this, actually I don't know, I don't use this result anymore, so I have to calculate 16 times 4 times 2. I think this is something I can use in this question. So in this way, how many times do I have to do the multiplication? It should be log n, because let's think I have more like this. In this case, Actually, when I calculate this, I already know this part. So for this 4 twos, I actually don't have to calculate this or even this. I just need 16 and then I calculate 16 and I get 32. So the number of multiplication I have to do is in this layer once and in this layer twice and in this layer twice, etc. Right? So in total, this depth is log n, base is 2, log 2n. So n, every time I have to calculate twice, there should be 2 to the log n, which is O over log n. Okay. So log n of base 2. Yep. But this is the ideal case. Let's say I have something like this, and this. In that case, I have to calculate this, but I can ignore this as the constant, you know, factor. Okay. What I mean to say is, let's say I have to calculate n11. No, yeah, 11. Yes. In that case, oh wait. Yeah. So actually, I did it like the, base, bottom up way, but let's think a little bit more. Maybe I can do it in the top down way. Here, I have to multiply to 11 times. So I use the, formula here. 2 to the 11th, which is 2 to the 5th. Multiply this and 2 ones. Yep. And here, to calculate this, so I do it in this way. So 2 to the 2 times 2. Yeah, in this way. So I basically divide this into 2 and divide the current n into by 2. Yeah. Then if there is a modulo, I multiply that 2 once. Multiply 2 once. Yep. So I think this is more easy than think. And actually, this modulo, which is represented by 1 more 2 multiplication, can be ignored because I can think of this as a constant time because this is only once. Yep. So let me implement the function this way. So I think I can use the recursion. Yeah, recursion takes more space, so maybe I shouldn't. No, I have to use the recursion. Yeah. Because when I do this, I have to think what's the result of this. Yeah, anyway, I have to, the space is not constant. So time should be log n again, and space should be O of log n for the recursion stack. Even for this, space is not constant. because yeah, let's forget this part. Yeah, because hmm, the point here is this is 8 twos, which is 2 to the something. For this 2 to the something, I can actually calculate this in the constant space. And for this part, it isn't. So yeah. But for calculating this in the worst case, um, by the way, I think this can take, yeah, this is not efficient because if there's 7, twos, calculating all of them takes all of n divided by 2, so time compressed isn't over again anymore. If yeah, the one I like to say is I have to take care of this remaining part more seriously, and this would cause some space complexity. I don't know. But anyway, I will go with this idea so I don't dive deep into this anymore. Yeah. So I can call this recursively, but the base case is if n is equal to 1, I return x. And if, yeah, so read should be this. And also if there is modular, then read should be multiplied by 2, and I return it. Okay. Yeah, so this is it. And yeah, I think this is the idea. So let me take a look. So I will do the dry run. So let me go with the edge case, this and this. In this case, if x is 0, n is 2. So yeah, let me go with this. X is 2, n is 0. So in this case, because n is not 1, I go to return x. Oh, this is problematic. No, I mean, if n is 0, because n is not 1, I go to line 61. And n divided by 2 is 0, so I call this recursive function with x and 0, which is the same argument with the first one. So this causes the infinite loop. So if n is 0, so what should return? I should return x. Yeah, okay. So in this case, no. If x is 2 and is 0, I should return 1. Yeah. Oh, so here I should return 1 because something to the 0 is always 1. Yep. In this way, if x is 2 and is 0, I return 1. I pass this test case. Okay. For this, if x is 0 and n is 2, for 3, I go through these if conditions and I go to line 63. And I code this with 0 and 2, and I code this, but omit it with 0 MP. For now, myPow, x is 0, n divided by 2 is 1. I code it in this way. Yeah. And because n is now 2, which is puts modulo with 2 is not 0 to 1, I go to line 70 and I return this one. And here, for this MP01, this part should be, because n is 1, in line 66, I return x, which is 0. Okay, so in the end, 0 to the power of 2, so it should be 0, so I return 0. Okay, I passed this case. So the case I couldn't cover is in line 69, n divided by 2, sorry. The modulo of n divided by 2 should be 1. So let me try with something like this. So in this case, also, sorry, I didn't cover the case n is 1. Let me quickly check. In this case, I expect this to return 2. And actually, in line 69, this returns x, which is 2. I pass this. Okay. So lastly, if n is 1, no, n is 3, I go to line 71. So this should be times 2 here because of the line 79. And for 0, 1, this is 0. Sorry, let me test with 2. For this one, this should be 2. Because in line 72, if n is 1, this returns x, which is 2. So in the end, I return 2 to the 2, which is 4 times 2 is 8. So this returns 8, and as expected. Okay, so I covered all the lines and pretty confident in my code. So let me submit. Oh, I see. So I see. So n can be negative. So let me change this to. So if the power is negative, I should think of 1 divided by, I think, like for power of, 2 to the 3, 2 to the negative 3, and be calculated as 1 divided by 2 to the 3. So I use the helper function, myPow with positive power. Let's say my positive power. Yep. And I assume here that, okay. N is larger than 0. So if n is 0, I handle it here. If n is larger than 0, I just return my positive power. Like this. But if n is larger, small, sorry. If n is positive, I calculate in this way. But if n is negative, I multiply negative 1 to n, and I return 1 divided by this. Okay. So here, I assume that n is larger than 0. And if n is larger than 0, and if n is 1 is covered here in line 83, n is larger than or equal to 2, So n divided by 2 should be 1 or larger. So oh, this assertion is always met. Okay, so let me submit my code. No, 2.1 and 3. Hmm. How could I get this? Ah, I see here. I have to multiply x. Yeah. Because I always cover this with x is 2. I couldn't cover it. Notice this, but yeah. I have to multiply x here. So overflow error 34. Numerical result of out of range. Ah, sorry. I should call my positive pole. Okay. And I try this again. No. Numerical result of the range. Previous line repeated 15 more times. Seems like the recursion is the problem, maybe? Let me search this. Yeah, so this means obviously the number is too large. Okay. So hmm. Mm, mm, mm. Wait. So hmm. Let's say I change this. No. So sorry, let me search this error message more. So it seems like 2 to the power of 15 should be larger than this, maybe? No, it can't be. Let me print out. Oh, so many times this is called. Let's see. Wait, 2 and 1. What's the problem with this? So it's going back. Actually, I could reach this. So if n is 1, I should return x. But this is more than 15 times. What I'm having in my mind is Instead of dividing by 2, I should divide by 3 or maybe 4 or larger number. Hmm. Oh, it's going back. Maybe too large, does it mean? Yeah, obviously this is too large. Maybe. What's happening here? So let me try what happens if 2 and positive this number. So, sorry, it doesn't work. I actually don't understand what this error means exactly. But yeah, let me think how I can, you know, avoid this deep recursion. Mm. Mm. Okay, let me quickly update something and see. Like this. Probably this doesn't matter, but I just want to try. No. But why 34 times? But if I put negative. Oh, this is better error message. Why is it? Numerical result out of range. I think, how can I avoid that? Hmm. Any smaller than 0. I return this, yes. Yeah. What's the problem here? Because it could reach the bottom of the recursion and it going back. And when it going back in the middle, this becomes a problem. But if I think that's not the problem of the recursion depths. Oh wait, am I misunderstanding something here? X to the n. I see. I see. So maybe I can change this. Let me try a little bit. Instead of doing this, I check this inside of the recursion. If n is larger than 0, I return this result. And if n is smaller than 0, I actually have to return 1 divided by this. So let's say take absolute n. So what I mean is absolute power n. Doing this, and if x is smaller than 0, I return 1 divided by this, and otherwise I return this as it is. Okay. And actually I don't need this to be the helper function, like this. Oh. So I don't need this here. So n is 1 or maybe -1. Wait, this is the base case. Sorry, wait a minute. N divided by 2. This is actually not absolute. So let's say I written this. So these are two edge cases. And here instead of doing this, yeah, so this part is fine. But if n is say -5, -5 divided by 2 is, I don't know, let me check it. Okay, so -5 in Python. This returns 3. So sorry, -3. So this is as maybe expected. In this case, this is the base case. I don't have to take care of this. If it is -2, then this should be -1. Okay, -3. this should be -2 and modulo should be -1. No, +1. Let me check it. Yeah, correct. Okay. So basically I can use this. Yeah, just right. I don't have to distinguish if n is negative or positive if I do this. But no, I have to distinguish here. If wait, yeah, it's fine. I don't have to distinguish here. I just have to distinguish in the base case. Okay, let me check. Sorry, typo. And this can be myPow. Oh, it accepted. Okay, accepted. So it was quite tricky. So when I did something like this broke. But instead of doing this, if I distinguish the base case n1 and n-1 in the recursive function here, it didn't break. And if I do the distinction of the n positive or negative for the router popped, I didn't have to distinguish them. Yeah, quite tricky. Okay, so anyway, oh, this is correct. Yeah, I also updated this. Okay, so let me quickly wrap up the text of the question. Power power xn, and for this question, I use the recursion. So in each recursive function, I divide n by 2 and calculate x to the power of n divided by 2 to the 2. And also I have to multiply x again if n can be divided by 2 and if there's modulo 1. Yeah, and I had to distinguish the case when n is negative in this way, in base case, yeah, to avoid it breaking. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.